Hey guys, let's talk about this review sheet. So all these are going to do with rates and integral expressions and Riemann sums. And in the first one, we don't actually have to do a Riemann sum. We just have to write and then interpret what one of these integral expressions means. So this function f is modeling the traffic flow, and so I want to write an integral expression to find the total number of cars. And so since I have the rate at which cars are going through this intersection, if I want to write that integral expression, I can take the definite integral from 0 to 30 of f of t dt. And we can leave it just like that. Since f was defined in the problem, we can just write f. You know, we could have said, or 0 to 30, 82 plus 4 sine of t over 2 dt, but that is just f. So we can say f of t dt, and then the reader can look and say, oh, what's f? F is that. So either one of those is fine. When looking at part B, what I like to kind of do is let's figure out what the units of this integral are going to be. So f is measured in cars per minute. So f is measured in cars per minute. Time is measured in minutes, and then 1 over 15 would be 1 over minutes. So when I look at this, my final answer is going to be cars over minutes. So what I have is the average rate at which cars pass through the intersection. So 1 over 15, 15 to 30 f of t dt is the average rate at which cars go through the intersection in cars per minute from t is equal to 15 to t is equal to 30 minutes. So it's always average when you have 1 over, and then what does that function f model? It models the rate at which cars pass through the intersection. In this problem, we just want to be a little bit careful about what part A is asking. So in the table of values, we're given the diameter of the blood vessels from 0 to 360 millimeters. And A says to write integral expression in terms of B that represents the average radius. So when we're thinking about the diameter and we want to talk about the radius, we just have to remember the relationship between the diameter and the radius. So whenever we want to do the average of something, we want to take the definite integral from the start to the finish, and we want to divide by how many units are in between there. And if we have the diameter, to find the radius, we want to divide that by 2. So just recall the relationship between the diameter and the radius is that if I have the diameter and I want the radius, I need to take the diameter and I need to divide it by 2. We're now going to evaluate this using a midpoint Riemann sum, using the 3 subdivisions. So from 0 to 120, 120 to 240, 240 to 360. Each one of these is 120 millimeters wide. And if we want to do the midpoint, We're not going to do the left, not going to do the right, but we're going to do the value that's in the middle. Not the left, not the right, but the middle. Not the left, not the right, but the middle. And let's be careful, because when I take 30, 30, and 24, remember that we want to talk about the radius, so I'm not going to use 30, but I'm going to use 15, because I want the average radius, not that average diameter. Plus 120 times 15, and then 120 times 12. This is equal to 5040, and then we need to divide that by 360 to find the average. So we get 14 is the average. Okay, so those are the first two questions. Pretty short, pretty concise. I think I'm going to do 3 and 4 in two separate videos just to make it easier on you guys.